Hello everyone, welcome to my channel. My name is Sheikh Xavier Khan, and this is my first video. And in this video, we are going to learn something super useful and easy from compiler design. Today we will understand what is a context-free grammar and how we can build a parse tree along with leftmost and rightmost derivation using a very simple steps and examples. So let's get started. In this video, we are covering all these points: context-free grammar introductions, parse tree, types of parse tree, ambiguity in context-free grammars. So first, we have understand what is a grammar. Grammar is a set of rules which checks whether a string belongs to a particular language or not. In compiler designing, grammar means a set of rules that tell us how to write a correct sentence or a string in programming language. Just like a grammar in English helps you make proper sentence, grammar in computer science helps the computer understands your code. In short, grammar is a rules for writing a correct programs. Context-free grammar. It is a notation used to specify the sentence of a language. Context-free grammar is used to design a parser. Context-free grammar is a collection of four tuples. Context-free grammar is a set of rules that tells how to form a valid string in a language. Context-free grammar, consisting of a finite set of grammar rules, is a quadruples, which is N, T, P, and S, where N is a set of non-terminal symbols, means capital letters like A, B, etc. And the T is a set of a terminal, means the terminal means is small letters, where N intersection T equals to null. P is a set of production rules, and S is the start symbol. Now we have take one example on context-free grammar. The grammar, this A is a non-terminal and this ABC is a terminal symbols. Production rule. This is a production rule. This is a production rule. This means we can replace non-terminal A to terminal and non-terminal, and this is the final step. When you stop, you end A with A, B, C. Let's make a string. It starts with A, which is non-terminal. Apply the rule first. Means convert this non-terminal into terminal and also non-terminal. And again apply the first rule. And now we can apply the second rule. Then the final string will be become like this, like that. Now we can discussing what is a parser tree. In compiler designing, a parser tree, also called a derivation tree, a tree representation that show how a string is derived from the start symbol of context-free grammar by applying production rules. A parse tree represents the syntactic structure of a string according to a context-free grammar. Generation of a parse tree. A parse tree is an ordered, rooted tree that graphically represents the semantic information a string derived from a context-free grammar. Representation technique. Uh, Root vertex must be labeled by the start symbol, and vertex labeled by a non-terminal symbols, leaves labeled by a terminal symbol or epsilon. For example, S is a now construct the parse tree for this grammar. We will apply a production rule. Production rule S drives. Oh my god. I'm not perfect in this, but I will try. S drives A S and B S. We will apply a production rules. S drives A S B S. And for this production we will apply as A and S. For this production we will apply epsilon, and for this production we will apply epsilon. Epsilon is nothing but empty, and the final string it will be A and B. This is a final string, and this is a root node, and this is a parent node, and this is a branches, and the finally leaf node are constructed all be a terminals. Like this is a leaf node which is a terminal, and this is a branch node which is a non-terminal, and this is a parent node also this is a non-terminal. Types of the parse tree. There are two types of the parse tree: top down parse tree, bottom up parse tree. Top down parse tree starts with the string symbol S. A top-down parse tree is constructed as starting from the start symbol and expanding it downward by applying its production rules until all leaves are terminals that match the input string. This approach follows the leftmost derivation, always expanding the leftmost non-terminal first. Means in the top down parse tree used in a recursive descent parser works well for the uh, left to right scan, leftmost derivation. In the bottom up starts from the leaves. Means in the bottom up parsing is the process of constructing the parse tree from the input string upward by reducing it to the start symbols using a grammar rules in reverse. It is based on the rightmost derivation in reverse and is used by a left-right parser means starts from input string terminals, group substring handles and replace them with the non-terminal using the grammar rules. Repeat until only the start symbol remains. Proceed upward to the root, which is the starting symbol S. This is the starting symbol S, and this is a leaves node, and this string is start from this here. From this, the input string upward by reducing it to the start symbol using the grammar rules in reverse. Now we can take one example. um, Now we are taking some one example. We are taking some one example. What derivation rule? Let a context free grammar. This is given a grammar, and S is the non-terminal and AB is a terminal. String starting symbol is S and production rule is this. Now and and our goal is drive the string A B A A B B using this grammar rule. Step by step derivation from top to bottom. Starts by breaking the main S into two parts. Main S into two parts. Now, for the first S replace the first S with ASB, which ASB. Then replace the S inside inside ASB with epsilon. So it becomes ABS. In ABS, now we can replace the second S with ASB. The second S with ASB. Replace the inner S in ASB with ASB. This S is replacing with ASB. This S is replacing with ASB. Now finally replace the last S with epsilon, means empty, and you left with the string. So the string is A A A A B A A B is formed correctly. Parse tree shown on the right side. In this right side, the tree shows how each S gets expanded using the rules. Each orange ovule is a node, either S, A, S or epsilon. The tree starts from the top with S. This is a root node. It splits into a children's based on the rule applied like S. The terminal converted, non-terminal converted into the terminal, non-terminal and terminal also. Like that, this terminal is converted. This non-terminal is converting into terminal, non-terminal and terminal. Leaves of this bottom level spell out the final string. This is the leaf node. This is a leaf node. The leaf node are terminals, and this is a branch node. And final string will be final string is A, B, and A, B, B. One minute. Final string is this A, this B, this A, and then B, B. Final string. Types of this parser or derivation tree. There are two types of this parser or derivation tree. Leftmost derivation or rightmost derivation. Leftmost derivation is obtained by applying a production to the leftmost variable in each steps. Rightmost derivation is obtained by applying a production to rightmost variable. In rightmost derivation, we always expand the rightmost non-terminal first. And in the leftmost derivation, we always expand the leftmost non-terminal first. Now we have take one example. Let in a production rule in context-free grammar be this is a given a grammar, and find the in this grammar we can find the leftmost and the rightmost derivation for the string A. For this string, first we have to find the leftmost derivation. In the leftmost derivation, we always expand the leftmost non-terminal first. Means we can they starts with the non-terminal. This S is replacing this S is replacing with this, and now we can take a leftmost non-terminal first. Means this S is replacing with A, and replace the leftmost S. Means the leftmost S is this, and we can replacing this with A. Now replacing the next X with S into means non-terminal into non-terminal, and replace the leftmost S. Now we can apply replace this S with A. Means this is will become. Now we can replace the this last S with A. Means this last non-terminal with terminal. I will explain again this. First we have replacing this non-terminal into this non-terminal, and we have to replacing the first leftmost. We have to replacing the leftmost non-terminal first. Means this is we can replacing this S. We can replacing this S into this A. Now we can replacing this S in we can replacing this non-terminal into terminal, and then we can replacing this non-terminal into this, and again we can replacing this non-terminal into terminal like that, and now we can replacing the last s which is a non-terminal and replacing it into the terminal, and we can, here is a parse tree. um, is not this is non-terminal, and we can be listening with this non-terminal, and also, and then we have to replacing the first replacing the leftmost non-terminal means this s, we can be, no, we can be replacing this s, this non-terminal into the terminal. Now we can replacing this into this. Now we can replacing this non-terminal into the terminal and this non-terminal into terminal. Then we can creating this final string this. Now we can look at the rightmost derivation. In the rightmost derivation, we always expand the rightmost non-terminal first. Means in the rightmost derivation, first we rightmost we can replace the rightmost non-terminal first, which is this is the rightmost non-terminal. We can replacing this non-terminal into the terminal, and we can replacing this non-terminal into this non-terminal again, and now we can replacing this is the rightmost non-terminal, this rightmost non-terminal into this terminal, and the last non-terminal we can replacing with this non-terminal, and we can creating this final string this. I hope you can understand these problems, and now we can explain, we can explain the ambiguity in context-free grammar. Ambiguity in context-free grammar. A context-free grammar, ambiguous is ambiguous if there, wait a minute. Ambiguity in context-free grammar. A context-free grammar is ambiguous if there exists more than one leftmost or rightmost derivation for the same string. As a result, ambiguous grammars leads to a multiple derivation trees for a single string. Means a grammar is ambiguous when a single string can have a more than one parse tree or more than one derivation. Context-free grammar is ambiguous if one sentence string can be understood in more than one way using that grammar. We can explain one example, which is a real. We can explaining one real life example, just like in English. I saw the man with the telescope. Did I use the telescope to see the man, or did the man have the telescope? Same sentence, two meanings. We have we can explaining this example, one more example for this ambiguous grammar. For the grammar G, the string A, this string has a multiple derivations. For we can obtain this string, we can be a multiple derivations. Derivation first is a rightmost derivation. In this rightmost derivation, we can, in the rightmost derivation, the rightmost non-terminal is first. Means this rightmost non-terminal is first. we can replacing this non-terminal into the terminal, which is A S B, terminal and non-terminal and terminal. And now we can replacing this as into terminal, then we can get this string. After that we can replacing this as this non-terminal as into the terminal. Now we can get a final string. In the leftmost derivation the leftmost non-terminal first. We can first we have to take the leftmost non-terminal, which is this. So that was all about ambiguity in context-free grammar. I hope you understand it easily. If you like the video, don't forget to like, share and subscribe. Thank you for watching my video. And yes, drop a comment if you want the next topic explained in a simple way. To see you in the next video. Keep learning, keep growing.